All right, well, I think we are going to go ahead and get started so that we have plenty of time. So we're really excited to have Banafsheh Rekabdar from Portland State University in the Department of Computer Science there. And so Dr. Rekabdar's research interests are artificial intelligence, machine learning, and deep learning. Her research has led to a series of papers published in a range of competitive journals and conferences. And there's a lot of acronyms for these journals. So I'll just read the ones that I can understand the words of: neurocomputing, neural computing and applications, neural processing letters. And she obtained her PhD from University of Nevada, Reno, and got many awards while there, including 2016 Outstanding Computer Science and Engineering Thesis of the Year, 2016 Graduate Student Association Research Paper Competition, 2015 Outstanding Computer Science and Engineering Graduate Student, and Outstanding International Graduate Student from 2014 and 2015. So really made a splash there, and of course is continuing to do amazing work as a professor. And so she's going to discuss the current state of artificial intelligence. So thanks for joining us.
Well, thank you so much for the introduction. So I'm very happy that I'm here today. So hi, everybody. My name is Banafsheh. And I know that the pronunciation of my name is very difficult. So that's why my friends and colleagues call me Violet. So Violet is the meaning of my first name. The violet flower means like Banafsheh. So here's a quick introduction. So I obtained my bachelor's degree in computer engineering. And then, there have been like a couple of robotics courses there in my bachelor's degree. Then I got very excited of the robots. And I at that time, I'm thinking, okay, so robots are really cool. And that was the main reason that I decided to obtain my first master's degree in AI with the focus on the robotics. So during my master's degree, I designed, I was very interested in the soccer. So I designed a lot of soccer game and making robots, teaching robots to play soccer. So it was really fun. And after that, I immigrated, I came to the US and joined like a robotics lab again in the University of Nevada, Reno. And I obtained my second master's degree and also my PhD degree in computer science, working with the robots. So this is like the PR2 robot, very amazing, big robot. And what I did for my master's and PhD degree, I tried to teach this robot to understand human actions. So that's what I did for my master's and PhD degree. And here I am. I'm an assistant professor of computer science in Portland State University. So here's my story. I always, as I remember, my major hobby was painting. I always wanted to be like an artist, a painter. And I really enjoyed painting. And so at that time, so before choosing my major, I started watching Big Bang Theory. And then, so I started to see, okay, I also like sciences. So I got very interested of the physics, chemistry, based on the Big Bang Theory. And then, I understood that, okay, so I like the sciences also very much. Also, I subscribed to a good number of YouTube channels of the sciences and started watching them. And then as I learned more about sciences, I got more excited. And somehow at some point I find it out, okay, so sciences, physics, chemistry, or even computer science, they're also some sort of artistic, some sort of art. And then at that time I wanted to choose my major. So it was kind of difficult for me. So I talked to a couple of people, and then because, I wanted to have more stable job in the future, I decided to pursue and go into the science direction. But at that time, I promised myself that I want to be a painter. I'm going to continue painting. And here I am. So these are a couple of recent of my paintings. And so still I like it very much. And so in Portland, for example, last semester, I attended painting class, watercolor painting class, and I am learning like watercolor and I'm enjoying it very much. And somehow in the future, I really want to have like my studio, have like teaching classes and teaching like painting classes and things like this. So here I am. And also let's backtrack a bit. So when I was a kid, I really enjoyed playing games. So I love very much playing games. And I remember that, so my father bought me a computer. And I remember that I spent a lot of time learning how to work with computers. So I started computer science from there. And I really liked, computer. It was very cool and very fun. And also I remember in my high school, there has been a couple of just a few, maybe one or two classes in my high school. They taught like programming languages. So the first programming language that I learned was like Visual Basic. And after that, I learned very few and, very basics of the Pascal. So I started like learning programming languages. At that time, I got it, like, it was like very exciting to me. It was really fun for me that like with just writing a couple of lines, so you can get like an output. And so after that, so I went to the computer science area. These days, so as we see, that's like, I believe that, so nothing's like greater than changing the world like with the technology. And, technology is not just related to computers or like smartphone or like tablets or like those types of things, as we can see, like in this world, technology is affecting like any fields, For example, technology is affecting entertainment, like physics, medicine, chemistry, robotics, transportation, space technology, pharmacists, and anything. So I think that it's really important. So if you wanted to pursue any different majors, not computer science, if, for example, you wanted to be a doctor, a physician, I don't know, an engineer, I believe that it's really important for you to learn at least some of the basics of the computer science, data sciences, because like in this world, there are like huge amount of data in any different fields, there is like huge and big data, and then somehow we need to analyze, these types of data. So this is really important that for us, our kid, anybody, learn some basics of the computer science and data analytics. So as I mentioned, when I was like in high school, there has been like a few courses related to like programming. I was really good, and I hope that and I see that there are like even more courses in high schools related to like computer science programming, and I as I've mentioned, so it's really, I think, necessary for everybody to learn at least a few of them. So unless if anybody wanted to, for example, flip a burger like in the future as a job, or like drive a truck, and then so I'm telling you, I'm sure that like in the near future, so robots will flip the burgers for us, and also right now, so we see that so there are a lot of self-driving cars out there. I'm sure that like in the next 5 years or 6 years or 10 years, so things will change. Technology will change anything. So it's good to know, what's that technology, how you can use that technology in your work. So about the computer science, so my idea, I'm here right now, like in the computer science major, and I'm telling you that computer science is not just about coding and programming. There is also even more important thing in the computer science area, which is algorithm. Because like in any different, majors, if you're a physician and engineer in transportation, any different areas. So we have like a lot of different problems. We want to solve those problems. So we should deal with problem solving. Problem solving is the first step in problem solving, is designing efficient algorithms, and then when you have your algorithm, which works really good and nice, then you can write, programs and write code for that. So it's really important to understand that coding is not, computer science is not just coding, not just programming, but there are like more important things like algorithms and also other concepts that we should start learning. And also I'm here, I like in computer science major. As I'm here, I feel like, it's really a fun area. It's a cool area. There are a lot of things that we can do like in the area of all of computer science. To me, computer is more like logic. To me, computer science is more like solving problems, finding solutions for different problems, and they're really, really fun. And I think that it's more like some sort of like, creativity in the computer science. So at that time, I wanted to choose like computer science major. And I wanted to say like if I'm a good fit in computer science major or not. And I believe that if you are also interested in computer science major, if you wanted to make sure if it's like a good fit for you or not, maybe it would be like a good idea to answer to these questions. It's important to ask that if you like mathematics or not. So, for like writing program, being a programmer, software engineer, I don't know. So you don't necessarily need mathematics, but it's really important that you have like basic knowledge of mathematics, because mathematics will help you to solve some of the problems, find solutions. It's important. You shouldn't be like very good and great grades in mathematics, but at least you need to like it because you need to use it somehow at some point. Another question that you need to ask yourself is that, are you a problem solver? So do you like it? Because there are a lot of problems that you need to find like solution for those problems, and consider that they're not giving you any I don't know, instruction manuals, solution manuals. It's not like IKEA. You're gonna buy like those furnitures. They will give you some sort of like instruction manuals, and then you're gonna start doing that. But it's not something like that, like in computer science. You need to find the solution yourself. You need to write the solution manuals, I don't know, instruction manuals yourself. So it's kind of challenging, but good challenging. And another important thing that you need to ask yourself is that, do you like constant changes? Tech companies, changing every day, and we need to update ourselves every day because things are changing. Like program languages are changing, new libraries like coming, new technologies are coming, and then we are just learning like every day and try to adapt ourselves to these constant changes. And another thing that's important is that, again, you need to ask yourself if you've done research on it, if you're ready to do that. For example, if I'm attending like any presentation or like anything, and then right after that, I'll go like Google it, different things, I need to do some research to like understand new things. And that's it. For example, if you want to solve like any problem, you need to Google it, find like a lot of solutions and see how you can use them like in your area. So that's another important thing. Another thing is that you need to ask yourself if you don't mind sitting in a desk for long hours, because it's gonna happen. So you're working with computers and you need to write like long hours like in a desk and work on like different problems. Another thing which is really important is like tight deadlines. It's a tricky one. Even for myself, it's still so challenging for me, because like in very tight deadlines, you need to perform really well. Sometimes I myself, I'm very good, productive in tight deadlines, and sometimes I'm not. So it's still like a challenge for me. So you need to find it out if you can work well like in tight deadlines or not. And so then I came to computer science, and then so here I'm gonna get you like some ideas that why computer science major, if you're interested like in computer science, like what are the opportunities of computer science major. First of all, you don't need to have like any program experience to entering like computer science major. They're going to teach you, there are a good number of courses that will teach you like programming. And you don't need to be as good as math as you think. As I mentioned, you just need to like it, have some background, and be ready to use it. But you don't need to be awesome, but you need, maths. And a great thing, if you pursue computer science is that there are a lot of huge amount of opportunities, internship opportunities in big companies, in Amazon, in Google, in Microsoft, very big companies. Everybody is looking for intern. So they're very, very well paid and great opportunities. You're going to learn a lot. We're going to work on real projects. You have like teammates, and you are going to do networking with other interns, other people who are working in those situations. So that's really great. And these, internship opportunities are really great in the computer science major. And of course, you can work remotely if you like it, because you're going to work with computers. You don't need to be like in a lab. You don't need to be there. Because you're working with computers, you can work like definitely remotely. That's another great advantage of like computer science major. And the salary, of course, upon graduating, so it's really good. I can tell you. Another thing that's good is that, you're gonna learn some skills, and then right after that, you can apply it in your job. For me, it's really satisfying. You're gonna learn some courses in the university or like in the college or like out there, and then you can apply it like in real world applications, and it's really cool and really good. And also the empowerment you feel upon graduating, because there are a lot of opportunities are available right after that. Okay, so after I got my bachelor's degree and then my 2 master's degree, I was thinking, should I pursue a PhD? Is it like good? Why should I do a PhD? So that was a question. So maybe if you want to pursue a PhD in the future, maybe you can consider this thing, because I got my PhD. First of all, you need to find it out that what types of jobs you're interested to, take. If you wanted to have like a career in academia, if you wanted to be like a teacher, a professor in the university or college, or if you wanted to be a researcher in a major company or major like organizations, and if you wanted to do research, be like a postdoctoral student, definitely you need like a PhD. And another thing about like having a PhD is that you're going to establish like an academic identity for yourself. Why? Because in the PhD, your job is like doing research, and then you're going to need to publish your finding in like different conferences and also in different journals. So you're going to publish a lot, and you're going to work on some unique aspects, on some unique areas, and people will know you with that topic. So that's actually a great thing, your academic identity. And that's actually, you're going to qualify for more jobs. So as I mentioned, there are a lot of opportunities out there that they need like PhD. Definitely, don't need to be overqualified, but you need to qualify for some jobs. For example, as I mentioned, like those major organizations, or if you want to work like for the government, or like some of the jobs that it's PhD is the requirement. So what I recommend to you is that go and see what you want to be like in the future, and if like getting PhD is like a requirement for that particular job, or not. Another fact is that like doing a PhD shows determination, you know. So I know, you know, if you're going to be like a PhD student, a researcher, nobody's going to push you. So you should push yourself, and you need to solve the problems yourself. And so you need to work independently, you know, so it needs very determination. You need to be very determined to reach your goals. It's not going to be easy, but it's very satisfying when you solve solution to different problems. And also getting a PhD will changes the way you think. So this is another thing. Because when you're getting like a PhD, you know, you're going to think in a different way. You're going to see everything as a like whole picture, and you're not going to be just one-sided. You're going to see like different sides of a coin. So that's like it will, you know, affect or the whole life, everyday life. And also you can express your passion. You can do work on anything. For example, you can be like in computer science area, work with psychologists, with biologists, with zoologists, I don't know, with like engineers. So there are a lot of opportunities there. So you can express your passion, you can follow your passion, you can do new things there. And of course, another great thing is like the ability to travel. As part of your job, you know, you're going to attend like a lot of conferences, a lot of workshops. They're going to be in different countries, you know, in different places, and you can travel, you can do networking, you can see like new people, and all of them are, you know, great. And okay, so now I'm going to talk about like academic jobs. So I'm there, so I'm a professor. So I'm going to share with you pros and cons of being like in academics in an honest way. So there is one thing that I like it very much being like in academics is that like in academia, every day is a Saturday. However, you work Saturdays. So this is the truth. And also the best thing about academia that I like it, it's like, you know, that flexibility and the travel. Your work's really flexible. You can work from any place you want. You can work with anybody you want. You can work like any time that you want. And also the travel, as I mentioned, a lot of opportunities, going networking, different conferences, workshops, you can give talk, and that's awesome. Well, let's go through the pros, good things about like academias. As I've mentioned, it's pretty flexible. And you have the ability to travel, which is awesome. And you're going to improve your skills, you know, constant changes. You're learning a lot of things along the way. You're every day improving your skills, writing skills, research skills, programming skills, applying, you know, your skills in different areas, working with different people, networking. So you're going to, you know, grow. And also you're going to contribute to field. It's also really cool because you're going to be like a mentor, or you're going to be like a teacher. You're going to be a researcher. And you are teaching other students, you know, other people, and then so they will teach other people, you know, you're mentoring some of the students, and then after a while they will mentor other people, and you're going to have like a very big impact, you know, in the world, which is really cool and good. And also you're going to educate the next generation. That's also really great, educating the next generation. So as I mentioned, also you can investigate your passion. You want to do whatever you want to do. You can research like in any direction, find it out if it works or not. So it's always kind of about like new things. And you're gonna work on a college campus. It's really cool, you know, I like it very much, you know, working like in the university environment. It's really live. The younger generation around you, all the campuses are beautiful. You're around a lot of labs, environment. So that's really good and refreshing. And another great thing is like the sabbatical. So this is, I think, the only job that you can pay, you know, you just take some time off and you're gonna be paid. And it's really good. You know, you can do whatever you want, research in a direction and going to different places. collaborate with different people. So these are all good things about academia. So let's see what are the, like cons or drawbacks of being like in academia. First of all, it's really difficult to find like a tenure track position because it's really, really competitive. And another thing is the illusion of the flexibility, So as I've mentioned, your jobs will be really flexible. So you have a lot of, flexibility. It's true. But the thing is, because of those flexibility, maybe sometimes, you need to work also even on the weekends, at night. So it's really, really flexible. And also it really needs a lot of, hard work. And also the income, definitely working like in industry, there's going to be like more income than like in academia. Okay, sounds great. So now I'm gonna talk about like the current state of artificial intelligence and machine learning and a lot of like great things that are happening, with this advanced like AI and machine learning, which are really cool. So I wanted to see how smart machines can do these days. So this is actually a very hot topic these days, and a lot of things are happening. So let's just see a few of them. First of all, cars are driving by themselves. So this is all because of like AI and machine learning, which is really cool. And also these days, speaking to a bot is no longer unusual. So we're talking always with the Siri, for example, or with our phone, So these are all because of those advances in AI and like machine learning. And also another great thing that happened in a few years ago is that like there is like a game which called Game of Go. I'm not sure if you already played with Game of Go or not before, but it's really complex game, really, really complex. It's not as straightforward as like chess. It's very complex. You need to have like a very intuition, to solve this problem, to play this game and win. But in March 2016, there's like a technology, reinforcement learning, a part of machine learning. They designed like an algorithm which beat World Go champion. So it was really one of the breakthrough that happened in 2016. Still, it's like a breakthrough. So yeah. And also maybe you have heard of like some technology called deep learning. So deep learning is like a part of like machine learning or artificial intelligence, and it's changing everything. So behind those autonomous car, those Siri, everything that's happening is like deep learning. This is like the new technology. And, this deep learning are trying to get like machines intelligent and as smart as, possible. So it's really great. So these are the founders of the deep learning. So here is like Yoshua Bengio, University of Montreal, and Jeffrey Hinton, University of Toronto, and Yan LeCun, University of New York. He's in the Facebook right now. So they are the three people, triangle, that are the founder of the deep learning, which is very powerful. And that's why we're making these high, level of advances these days. And of course, so a lot of, big and small industries, they're always are like in these areas, they're trying to do research in the deep learning area. They're hiring people who knows like deep learning, machine learning, AI. So this is like very, a hot topic. IT companies are racing into deep learning. So the question is, so because we had AI from a very long time ago, but it's just a couple of years, maybe 10 years, 15 years that, AI is getting hot topic again, and a lot of advances are happening. So what's the question is, what's the difference between this deep learning and other, classical machine learning? For the classical machine learning, we needed to a lot of knowledge. We needed to like formalize knowledge, expressed like neat, like a structured. But the problem is these days in different areas, there are a huge amount of data. It's like big data. So it might be languages, maybe speech, like images, videos, a lot of things which are not structured. And that's why we needed to make sure that computers get knowledge, data, and learn from examples. From the raw data, the input would be like the raw data, and then extract like useful knowledge from those raw data. So that's why machine learnings are really powerful, and they're different with like classical artificial intelligence methods. So let's see. So what is this deep learning? Deep learning is like, a part of machine learning. And machine learning is a part of a subfield of artificial intelligence. So as I mentioned, in machine learning area, there's going to be like input and output, something like this. For example, this is the input, this is like an image, and output, that's it. The overall idea, the deep learning, is that they're trying to, if they have like an algorithm, if they have like a model, they're trying to add like more layers and make it deep. So for example, there's like an input, there's going to be more layers. They're going to process this data in level 1, level 2, level 3, extract like more information in different layers. And that's why deep learning, works really well. But again, the question is why this deep learning method adding these extra layers is helping. So why is deep learning working so well? Well, maybe the answer is that because this idea comes from the brain. We are human, we're smartest creature right now, in the world. And then, so everything's based on our brain. So our brain is like have a very, very deep structure. So there are a lot of like layers in our brain. And somehow deep learning is kind of biologically inspired based on the human brain, and they're making it like super deep and extracting different things like from the data. Well, things going pretty well with deep learning. So let's see a few applications together. So one of the major areas that works really good with machine learning, deep learning, is image processing, is computer vision. This is like an example. Like this example called like ImageNet. This is like a very, very super, huge data set. It has like, I think 1 million images and with 1,000 number of passes. And then with deep learning, they trained a model that for the object recognition. For example, as we can see here, so these are the test images. So this is the true label of this test image, and these are like the 5 most probable labels that a smart trained machine predict. For example, for this one, leopard, jaguar, cheetah, and this. As you see, all of them are kind of related to this picture. So it's very cool. Or like this one. This is like a motor scooter, this image. And these are the thing that this, our trained machine, predicted. So they're all relevant because this data set was very big and it's really difficult even for a human and to do this classification. But with machine learning, we trained like a machine and great results. So there we go. This is like one of the models that works pretty well for this application. Can you see how huge and deep this model is? This is deep learning. So they're adding layers and layers and layers and layers and layers. And then using this huge model that works good for this very complex problem. So this is another great thing, like for natural language processing, for searching. Consider like this is a query, car parts for sale. For the search, you're gonna want to search it. With like traditional AI methods, the human number 1 will get higher rank, the highest rank. But if we read this, the human number 2 is more relevant to our query, selling all kinds of truck parts, engines, and transmissions. But the thing is, like between these two, this query and document number 1, there are more matching between the words. But the thing is, semantics more important than matching the words. So with the help of deep learning, we can retrieve like document number 2. This is another great application, that image captioning. For example, this is the input image. This is the output generated by computers. A cat sitting on a suitcase on the floor. Or like a tennis player in action on the court. So these are the inputs, these are generated by machines. And of course, these are some failure cases. For example, this is the input and the output is a woman is holding a cat in her hand. Or a person holding a computer mouse on a desk. Or this one, a woman is standing on a beach holding a surfboard, but the woman is doing yoga. Or a man in a baseball uniform throwing a ball. Or sees this like a bird perched on a tree branch. So these are some failure cases. And of course, there has been a lot of advances in medical research, breast cancer, predicting new drugs, or how to prevent different diseases. And it's another cool thing related to the eye, detecting like eye problems by using machine learning methods. And this is another great thing. So these are like some sort of artistic with the computers. So consider that this is like our input and this is the style. These are the inputs to the computer. We want to ask the computer to apply this style to this picture. And this is the results. See how cool it is? Or this is the input, this is the style, and this is the output. The computers apply this style in this input. Or this is like something artistic. Or another application is just like text to image synthesize, doing it like in a reverse. So this is like the input, and these are images generated from scratch by computers. Like the white and yellow flower have thin white petals and a round yellow stamen. So they're very relevant, they're generated by computers. Very cool. So as I mentioned, applications on the horizon, in security, safety, robotics, healthcare, a lot of areas definitely we can apply AI, machine learning, deep learning. Well, the question is, what is missing? Well, still we are very, very far from human level AI. We made a lot of progress, but we're not there. So our creators are not as strong as humans. I don't know, maybe in the future it happens or not. I don't know. I don't have the answer, but yeah. So overall advances are going towards that to obtain like human level AI. And also for the robotics, also there are a lot of things that we need to do, like with unsupervised learning. And of course, AI is really powerful. Machine learning is very powerful. Of course, maybe they can be misused, or on the other hand, can bring much good. So there's always pros and cons, in everything. But definitely, using machine learning AI, there are a lot of great things that we can do. For example, we can help the poorest countries. We can find climate change. We can improve healthcare, education. There are a lot of things that we can do that people are working like in those areas. So thank you very much. So I hope you enjoyed my talk. So please let me know if you have any questions.
Yeah, thank you so much. So if anyone has any questions, feel free to come off mute, put your video on, or if you would rather just put it in the chat, that's fine. I have some questions as well. All right. Well, I wanted to think back to your career trajectory a little bit and ask. Oh, wait. First, we got a question. Thanks, Urgav. Can you please explain how machine learning and deep learning differentiate? Now you did a little bit, but maybe a little bit more into that.
Sure, of course. Yeah, so deep learning are just one small part of the machine learning. In machine learning, there are a lot of different approaches, but in deep learning are more related to the one types of machine learning methods. One types of machine learning methods are called neural networks. Neural networks are designed based on the human brain, and then deep learning is focused on the neural network, and they're trying to make neural network, as deep as possible, making it even more similar to the human brain. And then we have different types of neural network. For example, recurrent neural network work very well on sequence data, or convolutional neural network works very well on images and videos. And there are different types of that. So yeah, so this is like one of the main differences between deep learning and machine learning. And of course, in machine learning, all the methods are just one layer, but deep learning, it's deep architectures. There are, I think, tons of layers, and then models are getting bigger and bigger and bigger, and also stronger and stronger.
And I have a follow-up on, so each layer is basically a step that involves processing data, right? So more layers mean there's kind of more different steps involved and complexity in the data and the way it's processing it.
Exactly, yeah. For example, consider that we have an image. First layer will just extract the edges, the lines, and then layer after that will extract more meaningful thing, and then the layer after that maybe we'll understand, okay, for example, there is a cat, there is jumping, there is human, and the layer after that we can understand, okay, so for example, a human and the cat are jumping, things like this. So each layer they try to extract more meaningful stuff. So yeah.
All right, so we have a question from Quincy. Quincy says, I just learned Unity over the past year, and I only have experience making video games. Where would you recommend I go next to continue growing my skill in programming and to learn more about how I can get involved with AI on my own or in my computer science class at school?
Yeah, that's really great. I'm very happy that you learned Unity for making video games. I know that this is very cool and also very not easy. So I'm happy that you learned that. So it's awesome. So definitely right now you can work on different areas. For example, if you're interested in videos, understanding videos or video games, there are a lot of methods that with deep learning methods that you can analyze those video games. Or another great thing about video games is that using reinforcement learning, you can have an agent that play in the video games by itself and learn how to play, as I've shown, for example, for the game of Go. So this is another thing, for the agents, we can train agents like that. This is another thing. Or also if you Unity, definitely also you can go to the virtual reality part and design games and models and environments for the virtual reality. So I see lots of opportunities based on your interest. Definitely we can go and but first of all you need to as you're saying, improve your programming skill. I recommend to you maybe C and Python languages, and after this stuff, definitely you can apply some of those AI machine learning. You can take some of those classes online. I can give you some resources, or I don't know, in your school. So, and then learn and apply. But it's cool.
And then Jordan asks, what type of ML research or projects are you working on now?
I'm working on reinforcement learning. So as I mentioned for that video game that I explained, what I'm very interested in is that somehow teaching like a robot or agent to interact with the world and do the decision making like human. So I'm interacting with the world, I'm making decision. So I wanted to design like an agent that do sequential decision making in the real world. It's really difficult. Or like, for example, training an agent to play a game and win the game, to do this action, for example, or that action, how to gain like more reward, get more scores like in the game. So this is what I'm very interested in somehow, because I wanted to design some sort of, I don't know, robots that can do, things that we as a human can do.
This is my question, have you taught robots how to paint?
Not yet, but maybe that would be a cool idea. Yeah.
Combine your passions.
Yeah, that would be a great idea, actually.
Well, what I was going to ask earlier is thinking back about your education path. You had done, you ended up doing 2 master's degrees. And so I'm curious what you think about, why you decided to do both, and then whether I know that making the decision, depending on what field you're in, some people will do a master's and then go into work. Some people will do a PhD without doing a master's, because depending on the field. So I'm curious how you made those decisions in your path.
Yeah, that's actually a great question. So when I got my first master's degree, it was like in the AI with some designing those like soccer games, which I like it very much, with simulation. And then I felt like, okay, I wanted to learn like more in that area, AI robotics. I like it very much. Then I decided to get like master's degree. I didn't think about like PhD at that time. And then I got my master's degree, and then after that, because I wanted to be like a professor, in the university, then I decided to get like my PhD degree. But the main reason for getting the second degree is that I wanted to learn, as much as I can, in the robotics areas, combination of AI and robotics areas.
Okay. Yeah, that makes sense. Any other questions from students before I go ahead with more of mine? So this is actually following up on what you just said, where you decided that you wanted to be a professor and work in academia, and you did go through the various pros and cons of academia, which I really agreed with. But I'm curious what other career options you were also considering, and kind of like how you decided, committed to the academia route.
Yeah, actually, so I really liked like programming also at that time, and so my options were like going to industry for those high-tech companies, or like being a professor. But I don't know, because I wanted to have like more impact, and I liked also teaching alongside doing research. And I really like doing research, in some of the cool areas. I wanted to also have those flexibility, I wanted to work on, areas that I'm very passionate about. So that was like the main reason that I came to academia, and I'm very happy, because I like teaching very much, interacting with the students very much, mentoring them very much, and I really enjoy, doing research. So that was the main reason that, I chose to become a professor.
Thanks. So I have a question that is more, this may, feel free to answer in as much detail or as not. But one of the things that we talk about in this program is the challenges that people face during their career. And I think that is particularly true for women in, tech, computer science fields. So I'm curious whether you have any experience with that, or anything that you'd want to share, or just, what your thoughts are on that.
Yeah, sure. It's completely true. First of all, I'm an immigrant. So my biggest challenge was like that language barrier that I had. So when I came to the US, and another thing that I understood is that in particular in the science majors, like computer science in particular, because I've been there. So as you're saying, the number of women and females are not that much. So that I've been like in too many classes that just a few like female students were there, and most of them were, boys. So this is also another challenge. So that's why right now I'm trying to, because at that time also I decided to be a professor because I wanted to be a role model, for other girls, that you can also, be a professor, you can be in the computer science area, you can do it because it's possible. So you can work like with robots, and they're like, all of these things. So that was like, another reason I want to be a role model for other girls, show that. So it's definitely possible. So if you like it, definitely you can do it.
Yeah, that's great. I definitely relate to that. And I think probably a lot of our attendees today appreciate that.
Mm-hmm.
I think, so you've talked a lot about how, being a researcher requires that motivation, that self-determination. And so I'm curious that whether for you personally, you find like you're motivated just to solve problems in general, and, you like to just see the day-to-day outcomes or solutions in your research, or if there's kind of more like potential broader impact applications that you're particularly excited about, especially for AI.
Yeah, of course. I think both of them are really important. So to make, some impact. So as you're saying, the broader impacts also super important for me. So that's also really, really important, that, for example, I'm designing something for this particular area. So maybe that would be also helpful for other like areas, for example, for the medicine, for other, areas. So it really has like broader impact. So I have like this flexibility in my job to do like research, design new thing, new methods, explore, new thing. And I hope that it would be like beneficial to other fields. So yeah, the broader impacts like very important for me. Yeah.
Mm-hmm. Yeah, I know personally, having worked in a molecular biology lab, there were some robots helping with things like DNA extraction and processing and all of that. So that's just a very basic example, but I think, there's a lot of potential to apply that to any field. Okay, Quincy asked, you talked about how you learned a lot from YouTube. Do you have a favorite educational channel?
Not because what I watched, so it was in the past, but right now I'm just Google it in the video. For example, if I wanted to like learn about something, and there are tons of great stuff are like out there. So if you're interested, you need to first find out what you wanted to like search for, like in which areas. Definitely if you Google it, like in the YouTube, there are a lot of things out there. So not just one of them. So at my time, maybe a couple of them were good, but right now there are even better, more things like out there. But I would be happy, like if you're interested like in any of the areas that I've talked, I would be happy if you just send me an email. I would be very happy to provide you resources for you.
Yeah, and I would encourage any students here who do find resources, if they want to share with everyone, you can always send them out to us and we'll share, or we've got, the intern roster. That's a way to communicate with people. And then, sorry, I missed Elena's question earlier. Where and how do you recommend someone who does not know how to code get started besides school classes? Do you have any kind of informal or online?
Sure. Yeah, definitely. So also if you send me an email, I can send you like more resources, but definitely I would recommend like if you're very new to programming, maybe you can start with Python. So that's pretty straightforward to learn. Also would be very helpful. A lot of resources are available. And also there are a lot of websites that you can start like learning. And there are a lot of also, IDEs out there. For example, there's Google Colab that you can learn those codes and then write those codes and get the results like online. So a lot of things out there. But again, just with YouTube, a lot of, materials are available.
Yeah, and I'll just say from the biology perspective, there's a book called Practical Computing for Biology, which is really well written and walks you through different basics of how, code works. And then I believe it has a specific focus on Python for the lessons as it goes forward, but it was really useful.
Yeah, Python is very good. So if you are interested, also if you wanted to go like in industry, definitely go with Python. Even if you wanted to do research, because a lot of libraries of machine learnings out there, all of them are like in Python. So if you learn Python, that would be wonderful for all of you.
Yeah.
So, yeah.
And conveniently, Saturday Academy actually offers some Python classes. I'm not sure if we have a high school class. I mean, all of you are busy with your internships, so you don't have time for a class anyway, but next summer, definitely check out our Python classes that are just, 1 week long workshop style. Let's see if I have another question. Oh, okay. So one last question that I thought of, unless we have any more in the chat. I don't think so. So you mentioned how deep learning is modeled after the human brain and the way that the brain processes info. So I'm curious if research into deep learning has then revealed anything about human learning that we didn't know before.
I think that's actually a great question. So that's always the discussion between neuroscientists and machine learning, deep learning people. So they're always discussed. Neuroscientists saying that believe that so neuroscience helping machine learning, and then also machine learning people say that, okay, so we have also findings that helping the neuroscience. So that's always some sort of discussion, but this is true, they're both way connections. So with deep learning we are finding some new thing that hopefully will help neuroscientists, and also back from neuroscientists we're trying to design those types of biologically inspired machine learning methods.
Yeah, that's cool. So if anyone here is doing neuroscience or other biology, then it could be a cool way to learn about how because when I hear neural networks, I just think of human neurons and everything. It's like you try to understand how that relates to the way that computers are processing info. So
yeah.
Cool. Well, thank you so much. It is 1, so we should wrap up. But again, it was really great to have you, and thank you to everyone who came. Maybe I don't think the students have your email address yet. You did mention that they could email you if they want.
Sure.
So could put it in the chat, or we can send it out. Okay, great, in the chat. Yeah, so copy that down. Anyone who has follow-up questions. And yeah, thanks again.
Yeah, thank you very much for having me and listening to me. So yeah, thank you so much. Okay.
Bye all.
Bye.